Good afternoon to all of you. I would like to start by thanking Dr. Rose for inviting me here. I was planning to talk about the exciting stuff that we are doing at a department just across the road called Center for Product Design and Manufacturing as part of the Indian Institute of Science. Dr. Rose just told me that I also need to share with you how exciting it is to design. I presume that you already know how exciting it is to design, but let me just reiterate that design is, when you hear the word design, we tend to take it in two ways. One is that it's a verb, to design, and it's a noun, a design. Now, a design is a plan. It's not the thing that you produce. It's a plan for various things that human beings produce as constructions, such as the chairs on which you are sitting, or the lights that are right now focused on me, or the laptop that I'm using, or the plan that you had made as to how to come to IISc to attend the talks, or the plan that led to the wonderful lunch that you have had just a minute ago. All of those are designs, or the plans of those. And the way in which you go about doing that is designing, or to design. The interesting thing about designing is that all of us design. In fact, human beings are particularly known for its competence for designing. But having said that, not all designs that we create are necessarily good. And because designing doesn't necessarily lead to good stuff that are designed, we need to have education in designing, which is one of the reasons we are all here, to share with you the excitement not only of doing designing, but also of learning how to do designs well. And with that very short introduction, I would like to start by saying the particular route that my department has taken into design education. I have deliberately misquoted Rishi Krishnan to saying that we want to move India from jugaad towards structured innovation. So I'll skip that. But primarily, I have been into design teaching for a long time. My background is I'm an engineer. And then I veered my way across to more and more design. And I'm primarily into teaching and researching as to what this thing called designing is and how we can improve that. Now, I would like to go back a little bit because this is about designing India in particular. That we have always had these two broad streams of designing that we could put under social innovation and industrial innovation. We talk about Akshay Patra scheme where a very large number of students actually get their meals, and the way in which these meals are cooked actually are enormous. It's an enterprise in itself. There are affordable toilets. Then there are industrial innovations such as nano that you all know about, but also Sumit that I would like to briefly touch upon. And it all started long ago, of course, but I just wanted to show you some early examples. Now this is about Tipu's rockets. Tipu Sultan was a king in this area a couple of 100 years ago. And what his army was particularly known for were the rockets that they had. And these rockets were the best in the world at that point of time. There were several battles that the Tipu had with the British at that time, and he won all of them except the last one. And what happened in between the one that he won last and the one that he lost was the following: that the British, being very good at structured innovation, they, after losing the battle, picked up the shells of the rockets that Tipu produced, went back to England and went through a rigorous reanalysis of how these rockets worked and why is it that they were so formidable. And they understood that, they re-engineered that, and they used it back on Tipu. And not only did Tipu lose the battle, but also later on these rockets were used to the French. So you could say that Tipu had a hand on the winning of the British over the French, the Napoleons. These are some other examples. The chic. These are the small packaging. There's a small company in Chennai that actually has one of the largest market shares in rural India for these small packagings. And what they understood very well, and well before many other companies, is that it's a challenge of right sizing, that people are not ready to put in a lot of money upfront, even though over a long period of time, the life cycle cost for buying a larger pack of shampoo might be less. And the other example is the one on the right, and that is from a company called Sumit. It's also got an interesting story. An engineer chatting with his wife because of the recently bought brown blender that got broken once again. And the lady asked her husband to fix it. And he, being an engineer, started looking at it and said, well, actually, it's not going to work at all. I can fix it now, but another 5 days it will get broken again. And he realized that this particular brown blender was not suitable for Indian cooking. We are used to breaking a lot of hard stuff. And this vacuum cleaner didn't, this blender didn't have the right motor size to do it. So he basically then put together a better motor, a more high-powered motor, and also put together some really fancy steel pieces together. And then there was this Sumit blender, which had actually occupied a fairly permanent place for many years in Indian cooking until it got beaten. So students, 400 faculty members, and fairly good research record. Center for Product Design and Manufacturing is the only department that teaches and researches in design, produce about 20 design prototypes per year, and there are also research into design. So here is the objective for CPDM. I'll get more into that. Essentially, we have got a 2-year Masters in Design program where we would like to train students with both engineering aspects as well as the ergonomic, functional, aesthetic, material, manufacturing, and marketing aspects. We also have the first PhD program in India that we started in 2003, and these are the 2 programs. So what are the particular elements of designing as we carry out at CPDM? One is that it has got a structured design process. I'll get into more of that. Second is that it requires immersion into user environment. As a designer, you need to get into the shoes of the person for whom you are designing, and that's something that cannot be done without being part of the environment that the user is in. Then the third is the technical orientation to address functionality and a very strong emphasis on realizability. There are many designs that are produced in India, but they are not realized well. And this is one particular weakness that we'd like to address. And there is very strong emphasis on learning by doing. There are things in design that only way you can learn is by actually doing it. And then there is this streak of research into design that we need to systematically also ask the question, we are designing, but how are we designing? Are we designing it well? Why is it that we are not designing it well, and how can we improve that? The domains in which we are particularly fortuitously kind of gotten into are meeting social needs such as water, sustainable mobility, biomedical devices, devices for the different abled, and so on. So here is the mix of students that we have. Just to remind you, these are master's programs only. We primarily take students from mechanical and production engineering, although it is not by choice. This is how the things have panned out so far in the last 12 years of our teaching. About 20 to 30% from architecture, and the rest from other domains of engineering. So they need to have an engineering or architecture degree to apply. And there is also a similar number of research students, primarily in PhD. These are the kind of courses that we teach. There are some courses that fall what I call under tools and skills. You need to know what are the skills that you need to develop, and people should be able to sketch well, they should be able to use various computational tools and so on. The second is methodology. There are processes that have been found in the past to be useful in designing complex products, and it makes sense to be aware of them and ideally being skilled at using it. There is also a strong element of engineering that is involved in anything that realizable that one produces. And it is just not doing good engineering can make a difference between a poor product and a wow product. There's also the managing of designing, the product planning, and so on. Then there is this learning by doing, huge focus on practice, and some focus on reflection, looking at like an outsider as to what one is doing as a designer. So here are some examples. There is a course called Creative Engineering Design, where we actually take the students in a 14-week course to start with the user environment, be in the habitat, understand the problems, develop ideas, develop prototypes, try them out, and so on. There is another course in which the students have to start only with computer. They cannot sketch anything, they cannot use any notebooks. They start with computers. On computers, they have to do everything. And when their design is ready, they just fire it. They actually create an engineering drawing, and they take it to the workshop, and they have to create the thing. So here is an example. What you see on the right is a virtual prototype. This virtual prototype was created in order to reduce the effort that people who sew the soles of the shoe to the top part have to use in order to stitch it. That's the hardest part of stitching the soles of the shoes to the shoe. So this is essentially a hole making machine or device that one can use. And the lady on the right had designed it, one of the students, and she's demonstrating that as part of the course. Then there is exploration, very strong importance on exploring lots of designs. As Linus Pauling said, the only way to come up with good ideas is just create lots of ideas and throw out the bad ones. And he got two Nobel Prizes, so I think we should give some thought to what he's saying. So the idea in the mini design project is that you have to produce lots of out-of-the-box concepts and then look at them in a systematic manner. Then there are reflection courses. There are two courses. One is a small course where the students are given a small design research project. For example, what does aesthetic mean for the visually challenged? What would a product interface be in the area where there are sensors everywhere? What kind of digital tools would you use for early stages of design? We know that sketching using a piece of paper and a pencil and so on have been used for long. And there are certain tablets that are now currently used. But are they good enough? There is an interesting challenge here. And how can you create lots of half-cooked ideas quickly on some kind of storage where you can reflect upon them? So it has to be sufficiently clear to communicate both to oneself and to others, and at the same time it should look that it's not finished, because things finished kind of fixate us to them. How can you take inspiration from nature, and so on. One of the things that we inculcate is that designers seem to flourish when there are constraints. So how can you give very strong constraints? For example, you have to use only formal computer tools. How does it change the way in which we design? Here is an example of that. This is a design that was developed by Himanshu Mishra, one of the Masters in Design students. So the challenge was that they had to develop a handheld hairdryer where there should be no heating element. So they looked at principles of other kinds and figured out that one way to do it is to create swirl and vortices in air and bring it to the areas where there is higher humidity between hair strands. So essentially the drying force would be a difference between the vapor pressure in the air and the saturation pressure at the same temperature. And the more that is, the more one would be used to use. So then with that, they created this, did some fancy evaluations and so on using fluid dynamics packages, and then eventually looked at various embodiments and came up with this hair dryer. That's basically got two fans, which can create a certain kind of swirl. So you basically take this around your head like that, and the hair is dried without a single heating element. And this is one of the products that have been patented. The final design project is where the students start in a roughly a year-long project, right from the need all the way to developing a functional prototype. It's done by a couple of students, and the evaluation is along all three dimensions of functionality, ergonomics, and aesthetics. And one constraint that we put in there is that it must be technically challenging, something that should ideally be patentable. And we are not very good at doing that. About 40% of all final year projects get patented. But we are getting there. So they start with the problem identification. Each student proposes 2 projects, and then we select a final project. About 1/5 are accepted for carrying out, and then there is a strong immersion involved there. This is one example of the outcome from that. This is a dialysis chair. Now, in a dialysis chair, what happens is there are 4 or 5 positions that are critical from a medical point of view. For example, they can get to low blood pressure, and they have to be brought in a place where the head is below the heart. So the blood actually gets pumped more into the head rather than to other areas of the body. So the technically interesting part of this device is that it uses only 2 actuators to get to all those 4 essential positions. And again, this is something that is not there anywhere, not just in India. This is a disposable syringe, which, as disposable syringes are, can be used only once and not beyond that. This is to avoid the transmissible diseases that are actually transferred because of reuse of syringes that are not meant to be reused. So this is a good example of a design for non-reuse. Okay, so this is the kind of things that the students have been able to produce. They produce 45 patentable designs, some startups, lots of peer-reviewed publications in research areas. And we are very happy to say that the research output is on par with the Center for Excellence, in the best center for excellence around the world, including Cambridge, Stanford, and Delft. So what are the main elements that we inculcate in design? It's a structured design process, strong technical orientation to address functionality, emphasis on realizability. If you say that your design is going to work, you must be able to show that it works. Learning by doing, research into design, and focus on meeting. So these are the 4 buzzwords that I would like you to remember, that for you to be a good designer, you must be able to immerse, you must be able to realize, you must be able to incubate. Your ideas must get out to the society, and you must be able to reflect. With that, I would like to take this from A.K. Ramanujan, that you need to have both fire and wind for the burning to happen. And that's much like knowing and doing. With that, I'd like to thank you for your attention. Thank you.